Good day, students. Welcome to mathematics class. We are still on mensuration of plane shapes. In this question, we are going to use it to understand the idea on how to solve a problem that has to do with similar triangles. The question says that in the diagram ABCD is a part of a right angle triangle ODC. If AB is 6 centimeter, CD is 15 centimeter, BC is 8 centimeter, angle BCD is 90 centimeter, and AB is parallel to DC. Calculate correct to one decimal place the height perimeter of the triangle ODC. So the diagram we have below explains what the equation is talking about, and the first thing we are asked to find here is OC, that is the height of the whole triangle ODC. So to find that, the simple way to determine it is at least to find OB, which is missing out there, is by making use of similar triangle. So from the diagram also, we have two triangles there. The two triangles that are similar, which are triangle OAB and triangle ODC. They are similar triangles because they have corresponding equal angles. For example, angle AOB, which is this angle, is equal to angle ODC, which is this angle, and angle DCO, which is this 90 degrees, is equal to angle ABC, which is this 90 degrees here. And they have angle AOB. They are sharing, both of the two triangles are sharing the same angle OAB. So because of this, we said that the two triangles OAB and triangle OBC are similar triangles. So to use similar triangles idea to solve a problem or solve a missing side of one of the triangles, we make use of what we call corresponding sides of the two angles. The ratio of corresponding sides of two similar triangles is a constant. That is, for example, considering triangle AB or OAB, we know that BO or OB is a side that is missing. We can find it by forming a ratio by saying that OB over its corresponding side in the larger triangle, which is OC, is equal to, we now can look for a side that is given for both sides. So is equal to AB in the smaller triangle over DC for the bigger triangle. So this is called the ratio of corresponding side, OB over OC, and this is also called the ratio of corresponding side, AB over DC. So in that case, we can say that this is a constant. We can use this to find what we are looking for. We call it ratio of corresponding sides of similar triangles. So let's say let OB equals S, and substituting values. If we substitute values, we have that X over S plus 8 is equal to 6 over 15. So cross multiplying, we have that 15S is equal to 6 into bracket S plus 8. Opening the bracket, 15S is equal to 6S plus 48. Collecting like terms, we have 15S minus 6S is equal to 48. Reducing, we have 9x is equal to 48, which means that 9x over 9, dividing both sides by 9, 9s over 9 is equal to 48 over 9. 9 cancels 9, and we have that S is equal to, using calculator, 48 divided by 9 gives us 5.3 centimeter. So therefore the height of triangle ODC will be equal to 8 plus 5.3, which gives us 13.3 centimeter. Correct to 1 decimal place. So moving ahead, we are asked to find the perimeter. Triangle ODC. To do that, first we have to find since this is a right angle triangle, triangle ODC is a right angle triangle, we can use Pythagoras theorem to find OD, because OD is the only side that is now missing that before we can find the perimeter, which is the sum of the sides of a shape. So OD is what is missing. So using that OD square, applying Pythagoras, we have that OD square is equal to DC square plus CO square, which is OD square is equal to 15 square plus 13.3 square, which will give us OD square is equal to 225 plus 13.3 times 13.3, giving us 176.89. 176.89. Adding both together, we have this loss 225 equal to, we have 401. 401.89. So that OD is root 401.89. That gives us 20.0 centimeter. So having found that, we now go ahead and calculate the perimeter. Therefore, the perimeter of triangle ODC is equal to 20 plus 15 plus 13.3, and that gives us that gives us 20 plus 15 plus 13.3 equal to 48.3. That is equal to 48.3 centimeter. Correct to 1 decimal place. Thank you.